Today's session is about correlation. Let's understand quickly what is correlation, its types and method of calculating it. Correlation: if the change in one variable affects a change in the other variable, the variables are said to be correlated. Measures degree of relationship between two or more variables. Types of correlation: positive or negative. A positive correlation exists when one variable decreases as the other variable decreases, or one variable increases while the other increases. A negative correlation, inverse correlation, exists when one variable increases as the other variable decreases, or one variable decreases while the other increases. Simple or multiple. Correlation only between two variables, simple correlation, and under multiple correlation 3 or more than 3 variables are studied. Linear or nonlinear. Correlation is said to be linear when the amount of change in one variable tends to bear a constant ratio to the amount of change in the other. The graph of the variables having a linear relationship will form a straight line. The correlation would be nonlinear if the amount of change in one variable does not bear a constant ratio to the amount of change in the other variable. Methods of studying simple correlation. Scatter diagram method. Karl Pearson's coefficient of correlation. Spearman's rank correlation. Scatter diagram method. A scattered plot is composed of a horizontal axis containing the one variable which is an independent variable and vertical axis representing the other variable which is a dependent variable. The purpose of the scatter plot is to display what happens to one variable when another variable is changed. Let us understand how to analyze the scatter diagram and derive conclusions. Scatter diagrams for different values of R are as follows. Let's analyze each of it. Here graph shows as X values increases, that is moves right, the Y value tends to increase, that is moves up, it shows uphill pattern. Here we see A is equal to +1, indicates a perfect positive relationship between X and Y. Here graph shows as X values increases, that is moves right, the Y value tends to decrease, that is moves down, it shows downhill pattern. Here we see A is equal to -1, indicates a perfect negative relationship between X and Y. This graph shows scattered value. Here R is equal to 0, indicates there is no linear relationship between X and Y. The two variables are linearly independent. If graph is like this, uphill, but little scattered, R is more than 0 but less than 1, it indicates a positive relationship between X and Y. If graph is like this, downhill, but little scattered, R is less than 0 but more than -1, it indicates a positive relationship between X and Y. Let's understand correlation coefficient, denoted by Rxy. The numerical value by which we measure the strength of linear relationship between two or more variables is called correlation coefficient. It is given by this. It's summarized in one value, the degree of correlation and direction of correlation. Correlation coefficient lies between -1 to +1. That is Rxy is more than -1 less than 1. Approach. Step approach. Step 1. Calculate the mean of the two series X and Y. Step 2. Calculate square of each value under X and square of each value under Y. Step 3. Multiply each value under X with each value under Y and obtain the product of XY. Then obtain the sum of the product of XY. Step 5. Substitute the value in the formula and interpret the answer obtained. Here we see it is always unit-free. For two independent variable, correlation coefficient is 0 and correlation coefficient is symmetric. Rxy is equal to Ryx. Let us understand clearly with an example. Example: A research physician recorded the pulse rates and the temperatures of water submerging the faces of 10 small children in cold water to control the abnormally rapid heartbeats. The results are presented in the following table. Calculate the correlation coefficient between temperature of water and reduction in pulse rate. This is the table. Solutions. Let temperature of water be X and reduction in pulse rate be Y. Step 1. Calculate the sum of the all elements in both the series X and Y. Step 2. Calculate square of each value under X and square of each value under Y, then obtain the sum. Step 3. Multiply each value under X with each value under Y and obtain the product of XY. Then obtain the sum of the product of XY. Step 5. Substitute the value in the formula. Here sum of X is 635, sum of Y is 63, sum of XY is 3835, sum of X square is 40,537, sum of Y square is 541, n is equal to 10, substituting and simplifying we get minus 0.95. Referring to this table, minus 0.95 falls between minus 0.7 to minus 1, which indicates strong negative correlation. Therefore, the result minus 0.94 indicates that the correlation coefficient between temperature of water and reduction in pulse rate is highly negatively correlated.